This lab is part of that, as you remember, part of the uh, part of the onslaught of labs around tic-tac-toe. And this one's really a helpful one and a useful one because it really teaches you about, introduces you and teaches you at the beginning of like iteration. What is to iterate over a loop in an array? And those are all different words, which if I say iteration, do you know what that means?
Yeah, I love iteration.
So what is iteration that you love
It's
so
where
much?
it does something for you many times. Like, so if you have an array,
Exactly. That's
it'll
exactly right.
each
Yeah.
element in the array. Like, so, like, if you could just check the array with iteration, or you could actually change something in every single part of the array. Like, I really like it.
Iteration. I mean, if you like it, that is great because you are iterating all the time as a developer. Iterating is like super helpful. I mean, because oftentimes you're dealing with data sets, and the data could be anything. It could be any size. It could be a small data set. Could be huge. Could be somewhere in between, and it could be data around user information. Could be data around like movies. Could be data around weather. I mean, any information is going to be data. And if you want to do things with each piece of that data, you have to iterate over it. And an array is a data structure. It's one of the data structures that you end up using as a developer. It's probably one of the most common data structures you end up using an array. Do you know what an array is? I'm sure you
It's like
do.
a list.
It's a list, exactly. It's a list where it's like in a bracket, and each item is assigned an index in the array. So the first item in an array is index number
0.
That's right. Index number is 0. And so it starts from 0 and moves forward. And you can push things into an array. You can pop things in an array. You can shift them out. You can unshift them. And you can iterate over through an array. So this lab is great because it teaches you a little bit about iteration using a very common iterative method to loop over an array. And then it also teaches you my favorite operator, which is the modulo operator, which is this
Yeah,
one right here.
that one's your favorite?
That's my favorite.
That's awesome.
Yeah, I love that one. First of all, I love the name. It sounds kind of like a comic book character, modulo,
Yeah,
like,
yeah, totally.
like an X-Men like arch villain, It's the modulo.
There will be no remainders.
Exactly. No, I love that method. I love the operator because I love what it does. It's not simple. Like the plus and the plus operator, the subtraction, the division, the multiplication. Those are all like pretty simple. This one, like, it's a little more nuanced because it's not necessarily about the actual thing it's operating. It's about the remainder of the thing. But we're going to get to the modulo operator in just a few minutes. And the last thing we're going to do here is we're going to learn about calling a method from inside another method, which is also really important, specifically when you're trying to keep to the solid principles of programming. Have you heard about solid principles?
Yes.
Oh, you
You
were
want
so
to talk
advanced.
about them? You can. I like it.
Exactly. So why don't we actually start with solid principles, just to quickly refresh ourselves. So this is from the source of all knowledge in the world, Wikipedia. And SOLID, which is an acronym. S stands for single responsibility principle. O is open-close principle. L is the Liskov substitution principle. I is interface segregation principle. And D is dependency inversion principle. So we're only going to focus on the S today, which is the most often occurs. The single responsibility principle, which essentially is the following: that every single method that you create, every single class, every single function, every single method should only have one purpose. It should only do one thing. If it does more than one thing, you're violating the single responsibility principle. That's not to say that there isn't times where you might want to violate the single responsibility principle, where you need to violate that principle. But when those moments happen, you have to make the case for it. And make the case to who? Make the case to yourself. And if you're working with a team, then make the case to your colleagues or to your boss in notes and comments in the code why in this instance it merits violating the single responsibility principle. But otherwise, more often than not, you're never going to need to actually violate that principle. because the reason why you want to do hue to that is because you can imagine, like, let's say you have, let's see here. I'll just create an example. This is opening up my portfolio site client. Let's just do, there we go. Okay, so let's say you have like a method, and that method is called the one thing method.
Okay.
And it takes an argument of a thing, right?
Right.
And this one thing method, I wanted to authenticate a user, and I wanted to, well, first of all, before I wanted to authenticate a user, I wanted to check their email and check their password. I wanted to authenticate them, and then I wanted to render a welcome page. Right? So that's what this one method, that's what I wanted to do. I wanted to check their email, I wanted to check their password, I wanted to authenticate them, and I wanted to render the welcome page.
Isn't that technically 4 different things?
That is 4 different things. So this is not a one thing method. This is a 4 thing method. Now, but what's the problem with this method is, well, this all might work, and this will all work perfectly well. You know, your check email, your check password, it'll be great. Your authenticate method will be great, and you're going to render perfectly. But what happens, like, if something happens with the authenticate part?
Yeah, like they can't remember their password, or
right. Or like, what happens if your logic in your authenticate user method here within your method is like broken somehow?
it's gonna mess everything up, right?
Everything's going to break because this is broken. And when you're trying to backtrace, so let's say, like, this is not just one method, but let's say you're working at a code base with thousands and thousands of lines of code and tons of methods. It gets a lot harder to backtrace and figure out, like, what's wrong when every single method is 4 methods or 4 things instead of one thing. As opposed to, you know, this method will check email and password because those are really the same thing. And then you're going to have another method that's going to authenticate, you know. And you're going to have autocomplete. And you're going to have another method going to render, et cetera, et cetera. What you end up doing is you're modularizing your code. You're making it into modules, which just actually end up helping you a lot down the road because code breaks. Code breaks over time. Code breaks because of user or developer mistakes. Code just breaks. And the more that you can simplify it and package into smaller components, the easier and better it's going to be for you to be able to go back and fix it, and also to update and to add enhancements or to change or refactor things as it will. So that's essentially why you want to keep your methods to one thing. That's just a super, super helpful thing. So that's the first principle within the solid principles, the single responsibility principle. So in this lab, what we want to do is we want to build 2 methods. We want to build one method called turn count, and we want to build one method called
current player.
So the turn count method is really going to be where the bulk of our logic is going to live. And in current player, we are actually going to call the turn count method within the current player method. And by doing so, we're actually exemplifying the single responsibility principle because we have built in the logic for turn count in its own method, and then we're calling it within the method that we need, as opposed to building 2 separate logic bases within one method. Does that make sense so far?
Yeah, totally makes sense.
Cool. Okay, so what are we doing here when it comes to the turn count method? So this method takes in an argument of the board array and returns the number of turns that have been played. A few things to think about. So we're gonna make an method that takes in the board and returns the number of turns that have been played. So how do we determine whose turn it is? So in Tic-Tac-Toe, that's super easy, right?
Yeah, even or odd.
Yeah. I mean, there's other games where I guess that'd be a lot harder to do. So
yeah.
we can be grateful that we're doing it at Tic-Tac-Toe, where Tic-Tac-Toe is a pretty simple game.
Yeah, I'm thinking just chess. Like, whoo, I guess you could do it by black or
Yeah, chess
Right.
is like super complicated. And given, you can imagine like how many possible iterations of moves there are in tic-tac-toe, like how much more so there is in a game like chess, right? Like having to build that out. Like,
Yeah. Whew.
you know, like every time you play those free chess games on like your computer or on like, you know, on your iPad or something, like when you're wasting time, like give props to the developers who made those chess games. Like,
Yeah, or solitaire even at this point.
or even solitaire, right? Like
I'm
those,
like, dang.
a lot of logic to build those games.
Yeah, it's pretty
We just
cool.
take for granted. Okay, so the way to do it is pretty simple, right? Because the first player will be X, the second player is O. So every even turn is an X, and every odd turn is an O. So that's pretty simple. And we're going to try to use an iterator like each to loop over the elements of the board array. And this is like an important thing here to remember too, that the return value of each is the original array in which you're calling that method.
Right.
You get that? Does that make sense?
Yeah, that makes sense.
Yeah, because essentially each, this is from the Ruby docs, so ruby-doc.org, which is like the all best resource to learn methods.ruby and look them up quickly. So each essentially calls the given block once for each element in self, passing that element as a parameter. So here's the example. If A is a variable and A is equal to a variable of an array equaling to A, B, and C, if you call each on A and print it, what you're going to get back is A, B, and C, right? Because it's going to print each of the values there. But it's not going to actually modify the existing array. This is a non-destructive iterator because it's actually not doing anything to the original array. As opposed to an iterator like map.
Yeah, and map I'm not really familiar with, which is interesting because I keep seeing it in different like labs or with different people, but like it's never been taught in the curriculum yet.
It will be taught in the curriculum. You're going to get there. You're going to map over map, and you're going to be like the map expert. You'll be like creating your own maps. But essentially, one of the big difference between each and map. And they're used kind of like as classic paradigms of the two different models, whereas each non-destructively iterates, meaning that it goes over the array without modifying the array. Map actually creates a new array where the value is returned. So
that's where you can like add one to every single part of the array or something like that.
Yeah, basically.
Or double it or
like here's a good example with like so here's A again, and A is a variable equal to A, B, C, and D in an array. So if you would call dot collect, which by the way in Ruby dot collect and dot map is synonymous.
Okay.
So if you call dot map, let's just say dot map, and you iterate it over with a variable X, and you want to return for every single thing in the array X plus an exclamation point, it will return a new array of A exclamation point, B exclamation point, C exclamation point, D exclamation point.
Okay.
So it's actually returning, it's modifying the existing array and returning.
Can I ask you a quick question about that?
Yeah, of course.
So let's say you had 1, 2, 3, and 4, and then you added 1 here. Would it actually add them together, or would it put like 1, 1? Do you see what I'm saying?
Let me try and see what you're saying. So,
okay, let's pretend like this is 1, 2, 3, and 4, and then collect.
Like up here, this is 1, 2, 3, and 4.
Yeah, collect, and then array plus 1.
Yeah.
Would it actually add in the 1, or would it put them together like 1, 1? Would it make it 11, or would it make it 2?
See what happens? Let's do it.
Yeah, I'm just curious. I'm like,
right? But the best way to find these things out is to actually just do it. So let's actually create this thing here. So we're going to create a variable called A, and A will be equal to 1, 2, 3, 4. Mm-hmm. Awesome. And then we're going to do a collect on it. Use the exact same language, X. And what do we want to do? We want to
add 1.
X plus 1, right?
Yeah.
That looks good. What did it
so
do?
It did add them together. Huh.
Pretty cool, right?
Yeah, I didn't know if it would make it like next to each other or if it would actually add them. That's pretty awesome.
That's pretty cool. So that's the answer. Whenever I have a question like that, I always just like, well, let's just do it.
Yeah.
Let's see what happens. It's to me, it's like that's one of the beautiful things about coding is like you don't have to always guess. Like you can actually just like do it. The answers are concrete. They're like real answers. And I love liberal arts. Trust me, I'm like a liberal arts person. But one of the things I love about coding is that there's like an answer.
Yeah.
Like, there's a thing. As opposed to like and one of the things I love about liberal arts is that like you can have a discussion in philosophy and there really is no right answer, and you can spend hours, debating
lifetimes,
which is like really fun. But like at the end of the day, sometimes it's nice to like have a solution or like an answer. There's a thing. Yeah. So that's dot each is a non-destructive enumerator, and dot map actually modifies and creates a new array. So that's important to know. Okay, so let's actually start here. So we are going to use the browser IDE because it's fun, and I haven't used it before. It's really cool, actually. Let me move this out of the way. There we go. Okay, so we're looking at our current player. Yes, okay. Let's do this. Oh, look at that. That's so cool. Good job, Flatiron developers.
Yeah.
Great job here. This is beautiful.
I love the little heart too.
I love the little heart. It is like my favorite thing. Okay, so let's take a look at the specs. Have you ever looked at a spec file?
Yes. And I was just wondering, could we use pry when we do it? Like I've only used pry like twice and it's really hard for me to figure out.
We can definitely try and use pry. That sounds great. I love it. Okay, let's use pry. Okay, but let's take a look at the spec file first, and then we're going to start building. And I love looking at spec files first before I do anything. Also because in real world coding, if you're trying to really keep to test driven development, to trying to build the test first and then coding to fit the test, you're going to want to look at your test file first to try and figure out what you need to do. And so in the Flatiron Labs, your spec file here, current player spec, is essentially your test file. And it's helping you shape what you're meant to code, which is the basics. It's the basis of TDD, of test-driven development. So it's like a good habit to get into, to look at your test file and really understand it, and then from your test file, build the code that works. So it's just a great like habit to get into. So, and also Ruby tests are written so well. It's just so intuitive to read them. So it says here, describe the current player. Describe the file, right? This is the whole Ruby file, and then describe the method within it called turn count on line 4. On line 5, it counts the occupied positions. So here in the test, it's going to create a board array where the first spot will be occupied with an O, and then a bunch of empty spots, and then an X, and then a bunch of empty spots and an X. And then it's going to expect turn count method to return back the number 3. Right.
So the test is going to plug in 3 tokens and expect there to be 3 tokens in that board.
Exactly right. And here, and that's, yes, exactly. And that's the whole method. That's the test for the method. Line 3 to line 10 is everything that we're being tested on for the turn count method. Line 12 until line 30 is the current player method. Interesting, right? There's more testing for the current play method than there is for the turn count method. But let's focus on the turn count method for now specifically. So we just have to basically create a method that counts the occupied positions.
Okay.
Pretty simple. Let's see if we can do it. So there's a couple ways we could possibly do this. Well, first of all, we want to create the method, right, with using our favorite Ruby method creator def. And let's call it turn count. And the turn count method wants to take in an argument of something, right?
Board. Board. Which is our array, right?
Which is our array, right? And it's the array that this file is going to be filling in with.
Correct.
Okay, so and also a good thing to do, practice, is always close everything before you even start coding.
Yes, because you don't know how many times I get a syntax error for a missing or an added in.
I get those syntax errors all the time. It's
like, dang it, syntax error, I know what you are.
exactly. I forgot to close something. And that gets even more helpful, by the way, when you're dealing with like JavaScript.
Oh, good.
And languages that don't have friendly closings called end, where the methods are like this. Yeah.
I'm not looking forward to JavaScript. I'm gonna be honest.
So like when you have methods like that and you're like, okay, first of all, you would break it down so that, you know, you would be able to read it better. But, you know, it's a lot less user-friendly and intuitive to remember where things are closed if you don't close them right away. So we want to count. So if we want to count, what do we need to create first to start counting with? Well, we need probably some kind of counter, right?
Yeah, we need a counter.
And we want to set it initially to 0.
Correct.
Cool. Not log 10. Autocomplete. Okay. Counter is equal to 0. And so now we got our counter. But we got to do something because we have to iterate over our board, right?
We want to each it.
We want to each it. Let's each it.
Let's each our board.
Each our board. So our board. So board.each board.each do. And what
and do is going to need an end. So I don't know if you want to go ahead and put that in down there or not.
We are definitely going to put it in. I just want to finish the syntax for the opening. Because do also is this, right?
Yeah.
Something and then do something. Well, not do something literally, but execute something and right. So
right.
It's board.each do, put something in pipes, and then do something with the thing you did in pipes, and then end it. So before we get to all of that, let's just put something in pipes. So what do we want to call the thing we're going to be executing?
Either token or something like that.
Yeah, let's call it token.
Yeah.
That sounds good. Cool. So board.each do with the token. So now we have our board array, and we're going to iterate it over each item in the array, knowing that we're iterating over a token. And we want to check if, well, there's a couple things we want to check for. We want to check if it's empty, and we want to check if it's, well, actually, is there anything, how many things we want to check for?
Well, we need to know if there's an X or an O in there, right?
Right, and that just tells us if it's occupied or not, right?
Right.
That's all we really want to know at this point, because the logic, and the reason why I say that is because the logic, and why I'm kind of equivocating, is because the logic for whether whose player it is actually not going to be encapsulated in turn count. That logic is going to be in the current player method.
Right.
So all the turn count method needs to worry about, all it needs to be bothered with, is how many turns have happened.
Right.
Whether whose turn it is, that's the separation of what do we call it? Solid responsibility principle. That's the solid responsibility principle. That's
some other method's job.
That's the responsibility principle. Exactly. That's some other method. This method, all we got to do here is just figure out how many turns have happened. So all we got to check here is what?
If there is a token in the space, right?
Right. And we don't want to do this, right? Because what is that?
That's equals. That's setting it equal to it. We need to compare.
Exactly. If token equals X, or if token equals...
Oh, and I learned that you can only compare 2 things. Like, you can't compare 3, because I tried that at a different lab and the computer did not like it.
It did not like it?
No, I couldn't do like something equal to array 0, equal to array 1, equal to array 2. It wouldn't let me do it.
You only have 2 things there.
Yeah, it can only compare 2.
Right. That kind of makes sense.
I tried because I thought logically, why not compare all 3 together? No.
Let's simplify my life, But here, so we're checking if the token, which is just ultimately is the nickname we gave to the variable name we gave to the element in the array that we're currently looking at, if that's equal to X or equal to O, then what do we want to do?
We want the counter to go up by 1.
And we're going to use this, not log 10. we're going to use this fancy
Incrementer?
operator. The incrementer. Doesn't that sound kind of like out of like the Terminator? Like
Yeah.
incrementer is coming. And all this is doing this.
And like I feel like the incrementer brings all the guns because he's adding one to it.
That's exactly right. He's adding one and he's making it equal to that new value.
Yeah.
Instead of writing all this, all we have to write is this, which is so much cleaner.
Yes.
Much cleaner than that.
Yeah.
Like, that just looks silly. You know?
It does.
You gotta have it, the first person who did that was probably like, we have to have a better way to do this.
Yeah.
It just looks so silly. So we're gonna get rid of that. And now so if the token's equal to X or O, then we're gonna add 1 to our counter. And so we have an each. This is the end of our thing here. Are we closing everything we need to close right now?
Yeah, because our
method
definition's closed and our if is closed.
And our if is closed. Is our each closed?
Does our each need to be closed?
Yeah.
Oh, our each needs to be closed.
So we are closing because we need to do this, right? Now it's a little cleaner.
Yeah.
Autocomplete. Okay. Well, what's the last thing we need to do? So this is closing our if. This is closing our each.
We need to call it, don't we?
We do. Because if we don't call it, what happens? We need to...
Nothing.
Nothing. Well, the logic will happen, but we're not going to see it.
Right.
So we need to do that.
Yep.
And that should do it. But you want to put in a binding.pry, right?
Yeah, yeah. I'm trying to learn pry so much. Like, and one of the guys, Bob, I don't know if you talked to him much. He wrote his code with pry, and it was like crazy amazing. I was like, what?
Where do you want to put the binding.pry?
Well, we want to put it somewhere where we want to stop the code. Like, so I'm not sure. That's the hard part for me. Maybe after counter plus or equals 1? Right there? Like, I don't know. You tell me.
Nothing happens.
So, nothing happens?
Well, let's see what happens.
And then we should be able to type in board, right?
Say it again.
Can we type in board and see what it does? Oh, yeah. See? We got a board. And look, it matches the one that we saw.
It matches the test, right? Because that's what's happening now. And if we type in token, it's showing us the token it's iterating on at the moment when we call binding.pry. Like, binding.pry is basically freezing the code in time.
So if we do exit again, we could get the next one, which should be X, right?
I think so. Let's try token.
And then if we do it again, we'll get the last X. What happens if we do it another time because there's nothing left in the array?
Let's see what happens.
Neil?
It just works. It just finishes executing.
Oh.
Binding.pry will keep on hitting pry as long as as long as we're still within the each happening.
Okay.
As long as we're still doing something with .each, as long as we're iterating. But as soon as we're done iterating, then this whole block, right? And a whole bunch of code is called a block, like a logical segment is called a block. This whole block will exit, and so when it exits, it'll exit this also.
Okay.
It'll exit binding.pry.
Cool.
And then we'll come to the next thing, which is counter. But it looks like we passed our first test. We can count the occupied positions.
Yeah.
You want to put binding.pry anywhere else? You want to see what else it does?
Oh, sure.
Where should we put it now?
I have no idea.
That's crazy. How about we put it here?
Can we?
I don't know. Well, we can, but what will happen is...
Will it change anything? It still does everything, right?
There's no token anymore.
Oh, whoa.
Why is there no token anymore?
Maybe because it's only picking up end? Like, I don't know.
It's a good question. It's a really important question because where does token exist? What's the, well, in other words, another way of saying that is what is the scope of the variable token?
Well, it's local up there in that method.
It's local to not to the method, but to this block of code.
Oh, okay. So it's not even to local to the turn count. It's just in
It
that.
exists within lines 5 to 9.
Okay.
It doesn't exist out of there because it is a local variable that we are using to give us a name for the iterated element of the array that we're working with. Right?
Okay. Yeah.
So instead of like it would be a lot more verbose if we couldn't just use a nickname like token to call each element in the array, because essentially what we're doing is it's like instead of token, it's kind of like this. It's like board 0, board 1, board 2.
Right.
Like that's what token is. Token each time it goes, well, token will be board 0 the first time.
What if you type board down there? What will it do?
Say it again.
If you type board at the bottom, what will it do?
Let's see. Like here?
No, like if you put in your binding pry and then you type board, will it recognize board from down there?
Oh, let's see. We're still in it, so let's see. Yeah, because why does it recognize board? Where is the variable board being defined?
Well,
where is it in our method?
I think it's in the test, isn't it?
It's in the test as an array, but what's the scope of our variable within our method board? It's on line 3, right?
Right.
We are actually creating the method taking in the argument of board.
So the binding pry.
Board is a global, not global, but it is
from 3 to 12, like it fits in there.
It fits. It lives in the entire method.
Okay.
As opposed to token, which we are just instantiating as a variable name, just so we can have something to call board 0, board 1, board 2, board 3, board whatever, as we're working our way through it with our each enumerator.
Gotcha.
So like that actually is just a super helpful thing to always think about. Like where do your variables and where do your variables live? Like how broad is their reach? Is it only within the method? Is it within the entire program? Is it within just the enumerator? You know, how local, how narrow is the scope of your method? Yes, your method, but also in this case, your variables as well.
Right.
Really helpful.
Yeah, that's interesting.
Yeah. So let's exit out. Okay, cool. So now we have our turn count. Yay, we can celebrate. Woohoo. Let's do our next one. So let's take a look at what it says. Okay. So it says, where were we? Current player. Here we go. So the current player method should take in an argument of the game board and use the turn count method to determine if it is X's turn or O's turn. If the turn count is an even number, the current player should return X. Otherwise, it should return O. And this is where we can have fun with a modulo operator. Because what makes a number even? What is even, right? It's not like a theoretical philosophical question.
It has to be divisible by 2 with no remainder. Yeah. I love it.
That's what makes something even. If it's divisible by 2 and the remainder is 0, then you have
an even number. Yep.
An even number. If not, you have an odd number. It's so simple. And then there's cool built-in Ruby higher level methods. We'll take a look at the end called even, odd, which is one of the reasons why I love Ruby so much, because they just have these fun methods like dot even, dot odd. You know, like, you don't get those in other languages so easily. You don't get fun like that. So all we have to do is see if whose turn it is. So now this method is going to have a lot more logic than our previous method had, because this method, as you can see, the spec is actually
more tests.
Right. So here, describe current player, line 12. Line 13, it returns the current player X for the first move. So if you have an empty board, then it expects the current player to equal X.
Right.
If you have, it returns the current player O for the second move, because XO, XO, XO. So if you have only one move on the board and it was X's move, the next move should be O. And if you have two moves on the board, O and X, then the next move should be
X.
X, right. Right. Because X, O, X.
Even though it looks backwards.
No, it looks backwards because
X went first.
Yeah, X went first. That's basically our method. So let's build that method.
Define. What was it called again? Current player.
And current player also wants to do something, right? It wants to
has
take
an argument of a board, which I feel like every tic-tac-toe has an argument of a board.
I know, right? You're like, I'm done with the board. No more boards.
I kind of like it. I'm like, tic-tac-toe, you want to argue about the board again?
Okay, so current player and the board. So we want to use the modulo operator, right?
Right.
So, and we also want to use the logic we just defined on line 3 to line 11. Because the line 3 to line 11 returns, what's the return value of line 3 to line 11? What does the turn count method actually give us at the end of the day?
The turn count gives us the number of turns.
It gives us,
should be a number.
This returns to us an integer, right?
Right.
And that integer is something between like 1 to 10, I don't know. You know, it gives us a number.
Right.
And what can we do with the number? We can check if a number is even or odd, right?
Right.
So the return value of this is an integer, which is just super helpful. To know
if it were a string, we would have some different issues.
you have to convert the string to an integer.
Right.
Okay, so we can do this. So let's do it. So if
the turn count board.
Isn't that awesome? We're calling a method within a method. I just love that.
I know. The first time I did it, I was like, what? And I love when you get further ahead and you're doing all kinds of methods in there.
It's like it's super meta. Like it's like we're like living in like this zone, this like phantom zone of like methods and methods and methods. It's like
it's using all kinds of cool stuff that you've already written, which is awesome.
It's pretty cool, right?
Yeah.
Okay, so if the turn count board, so if the return value of turn count with an argument of board, oh, there's my modulo, is divisible by 2, and that if the remainder of that is equal to
0,
what are we going to get?
We're going to get X because that's our even one.
That's exactly right. Now, there's a couple ways we could do this. We could do else if. Oops. Now, that works, right? Because...
But if you do that, don't you have to have an else with it?
That is the else.
I thought, okay, now correct me if I'm wrong here, but if you use the else if, I thought you had to have an if, else if, and an else.
I don't think so.
Huh. Well, I've been using that wrong.
Maybe I'm wrong. Only one way to find out, right? To actually do it. But what this is doing here is we're being very explicit in our logic. Because we're saying if the turn count board is divisible by 2 and the remainder is 0, return X. If it's divisible by 2 and it's not, the remainder is 0, return O. We could also do it like this, I believe.
Yeah.
And not have to do this part.
Right. Mm-hmm.
We could.
I did it the second way.
You did it this way.
Yeah.
Because and in many ways that's a better way, because you're being repetitive here. And another good programming principle is dry code. You know what dry code is?
Just simple, like not repeating.
Yeah, exactly. Do not repeat yourself. If I can type properly, do not repeat yourself. That's basically dry. And so this is a little repetitive. So why don't we just do else?
Okay. Yeah, I didn't even put the returns in mine because somebody was telling me that somehow Ruby just knows you don't.
It does. It does know.
And it took me a while to figure that out. I was like, why?
The returns are implicit in Ruby. You don't have to actually specify return. I put it in here because it's helpful when you're first learning to write it explicitly so that you just know what's happening.
Right. You know that it's returning that X or returning that O.
Because if you just have that, and you're just learning it, it's like, well, what's happening there?
Is it putting it? Is it printing it? Is it returning it? What's it doing?
You're like, if you type it, you're at least getting there. You're knowing exactly what's happening. You're being very explicit.
Yeah.
So let's see if it works.
Should work. And then I changed mine to a ternary operator.
We're going to get there right now.
But I don't understand the odd, what was the odd even one that you were talking about earlier? I didn't do anything with that.
Well, do you want to do a binding that pry quickly and see what happens?
Yeah.
Wrong place for it, obviously.
It was like, no.
Let's see what happens. Put it there.
That's happened to me when I had a mess up in my method name before. Like it wouldn't run pry at all, and I couldn't figure out why it was not running. Okay, there we go.
So if the turn count board is divisible by 2 and the remainder is 0, then return X. If not, return O. So let's see what happens if we type in
board.
Board. We got a board.
But it's blank.
Empty board. And then so if the board is divisible by 2 and equals to 0, is this divisible by 2 and equal to 0? There's no X, obviously not. What do we turn? Look at that. It knows the method. Isn't that cool?
Yeah.
Giving us an argument error. Wrong number of arguments given 0, expected 1. Meaning, I know what you're saying. Ruby's saying here, like, I know what you want to do, but you're doing it wrong. But the fact that it knows the method within this method is really cool. Turn count board. See, I call turn count board, and I return a value of 0.
Is that the O's turn?
That would be the O's turn, right?
Yeah.
That would be the X's turn.
Yeah, why wouldn't X go first?
And now board is this.
Okay.
Oops. I don't know what I just did. Okay. Okay, there we go. Now the value is 2.
So, it's showing you where in the array, right?
Exactly.
Is that what it's doing?
Exactly.
Oh.
All turn count does, remember, just returns us a value of the integer.
Right.
It returns us how many turns have happened. That's all it does. So cool. Okay, awesome. So now let's first do the dot even dot odd, and then we'll do
because those I haven't used.
Yeah, exactly. Let's move this out of the way. Okay, so I put it here somewhere. That's the ternary operator.
So even and odd are considered what? What are they considered?
So these even and odd with a question mark, these methods in Ruby are exactly what they sound like. It returns a Boolean. It returns.
Okay. Is it true that they're all even, or is it true that they're all false, or does it give you like whichever ones are even or whichever ones are false?
So let's do it for a second. A equals 4. A even, true.
True.
A odd, false.
False. What if you had like 1, 2, and 3?
Well, you need to iterate.
Oh. So these can't iterate. They can just tell you whether something's
true. Not an iterative method. What you could do is something like
select or select if they're all even.
1, 2, 3, 4, 5. B dot collect.
Which is the same thing you said was map, right? Map is collect.
Exactly. I'm just using it right now for fun.
I'm just trying to like get my brain wrapped around all the words.
See, you could use it within an iterative method.
So it's telling you the first number is not even. Second one is. Third one's not. Oh, that's cool.
Cool, right?
Yeah.
Or you could even do like if x dot even. Oh, and oops, sorry. I need to like make it better. I need to actually like make the logic. Okay. Ah. Don't type like me.
It's okay. You're doing great. Everybody types all crazy on here. Everybody. So the first one was nil because it's not even. And then the next one is even. So it says, I'm even. I love it.
So that's all it does. It's actually it's a really simple method. And they do what they say, which is pretty cool.
Are you an integer? What's a floor?
Floor. And as integer is already an integer, all these methods simply return the receiver.
That's weird.
Let's not worry about that now.
Yeah. So even odd. That's some cool stuff.
I mean, Flora does come up with like JavaScript. So like,
I won't worry about it till I get there. I don't really love JavaScript right now.
You will love it, or you will love to hate it. One of the two.
I think once I get through Ruby, I'll be a lot better at
like math.floor function returns the largest integer less than or equal to a given number.
Oh, okay.
So like math.floor 45.95 will return just the 45, right?
Yeah, and even if it's 45.05, it's still going to give you just the 45.
Exactly. That's like, and you could just see it. One of the cool things about JavaScript is you can run it in your Chrome console. So,
Yeah.
Right.
45.
Exactly. I don't need to exit. I just exit it literally. Okay. Cool. So let's do that in our method here.
Okay.
So now we're going to get rid of this.
Okay. Dot even question mark. Return X still, right?
Let's see if it works. It does.
It does.
That's a good way to do it. And then we can get rid of all of this. And we can make it a much, much simpler method. How can we do that?
Ternary operator, baby.
Ternary operator, which is awesome until it's not awesome.
Which is awesome until it's not awesome. Can you use the even with the ternary, or do you have to use the modulo or whatever?
Let's pursue it this way and then see what happens.
Okay.
We'll try both.
So what it's saying is the turn count is divisible by 2 with 0 remainder, put X. If not, put O.
Exactly. So the colon here is the else, basically.
Right.
And the first side is always the true element of a Boolean, and the right-hand side is the false.
Cool.
So, and as a left-handed person, I appreciate that the left side is the true side. I find I get this sometimes, so it feels good.
Yeah, this world's definitely rightist.
It's very rightist. We're in a rightist world. So that's essentially what's happening. So if we run the test here, it works, right?
Okay. What if you change that to even? Will it work?
That just looks silly, but let's see if it works.
We got 2 question marks. Just don't even know if that'll work.
It still works.
It still works. That's so weird.
Yeah,
the 2 question marks things is pretty weird. Like
the 2 question mark thing is weird.
It's kind of blowing my mind. I'm like, that's a little weird looking.
Now the challenge here is like when you have nested ternary operators, and that's when you start like not liking ternary operators. But when they're just a single layer, just like you're asking one thing and you only want one thing in return, then these are just awesome because they encapsulate your logic in one line. It's simple, but like if it's false, then do this. Something
else.
Et cetera, et cetera. Like
oh my God, yeah.
That's when it gets really not pretty. It's much nicer when it's just like this.
Yeah.
Yeah. And then when you start getting to like 3 or 4, well, anything beyond 4 layers in a nested anything, you kind of want to break that out. But when you even get to like 3 of these nested, you kind of want to just go back to this.
Yeah.
It's just easier on your own eyes, to figure it out. But yeah, so this is the way to do it. And so essentially what we've done today is we have really embodied the single responsibility principle because we've created a method that only does one thing, returns an integer, the return value of counter, and we increment counter based on if there's X's or O's here. This takes in that method and using a really succinct ternary operator, sees if the return value from this method is even or odd and tells us based on that whose turn it is.
Yeah, which is really cool.
Which is really cool. So this method in line 15 to line 22, or we could get rid of all this and say on line 15 to 17, how small is that? It's so
no.
On line 15 to 17, it does its own logic, and it also only does one thing. It returns X or O. That's all it does. And this only does one thing. It returns the value of counter. And together they're required to work together, but each one of them on their own can be modified without having to modify the other one.
Correct.
If you wanted to like make this one more succinct somehow and refactor it and make it into like a one-liner, you could do that and not have to worry that you're going to also break this one.
Right.
And if you break this one, you've probably broken it because you've done something here in this one.
Right.
And you know that. You can go back to it. So that's I would say the beyond like learning about tic-tac-toe and becoming a tic-tac-toe expert, that is the big takeaway. Hello again. That's the big
ton of takeaways
from this like lab. The big takeaway is to like modularize your code to make it as simple and uni-focused as possible, because it'll just make your life much easier.